I'm going to trace out this teapot diagram, and I'm going to create a file for the CNC machining. This is a full-size diagram. I'm using Logic Trace, and the first thing I'm going to do is I'm going to select the 4 points, which is going to define the 4 corners of my diagram. Shown here, you can see where I'm inputting the 4 corners of the diagram. Here I've selected Curve Fit as my method of tracing, and then Line, and then Trace. Also wanted to mention that red pencil on the right hand side there, I use that to mark off where I've started to trace. In this project, I switch between the 3 choices of tracing. I use Trace, Line, and Curve Fit, and you can flip back and forth. It's excellent. Because of these various trace commands, it makes the tracing fairly quick and accurate. Just wanted to mention that there are option and setup buttons that you can configure the program to suit the user. So like in my case, I've set up the trace line black, and I want it very thin like a thread, so it's 0.5 in width. I also wanted to mention saving your work, because when you save your work, the program creates a second copy, which I've nicknamed the working copy. What's great about this work copy is that you could pick up tracing the next day or even 3 days later, just load that work copy and continue your tracing. So you can see why I recommend saving your work frequently. Getting close here now to finishing up with all the tracing. So what I'll do now is I'll save that final DXF file, and I'm going to load that file into the post-processor program and create the toolpaths for the CNC cut. This project was a good example of taking a 2D diagram and converting it to an almost 3D carving. To give it that look, it was just a matter of cutting 3/4 inch material and rounding over the edges. That's what gives it the 3D look. Here I'm using Vectric Aspire 11.5. I'm going to create 2 toolpaths. One toolpath for the round over and the second toolpath to cut the project right out. And the lumber is 3/4 inch thick, so I'll be going down about 0.76. I'm also going to run the file through the simulator. This is the cherry blank mounted to the slave table. So the first cut I'm going to make, I'm going to use the round over bit. I'm going to do the whole teapot rounding over that edge. The carbide round over bit did 2 passes, and now I'm ready for the cutout. This is a close-up showing the round over bit. Here I've loaded in the second toolpath. This toolpath is going to do the cutout, and I've also programmed tabs to hold the piece in place. This is a close-up showing the 1/4 inch end mill cutting. I'm showing here a vacuum hose to draw up the sawdust, but I actually have a dust pickup, but if I use the dust pickup, you can't see the cutter. So I prefer not using the dust pickup and just use a vacuum cleaner to pick up the dust. One of the concerns I have is the tabs. The tabs have to be big enough, at least 1/4 by 1/4, to hold that teapot in place as it's being machined out, because I'm cutting right through that cherry wood right into the slave board. As the cut progresses, you do not want that workpiece to get loose and start to vibrate, because it's going to come out. The whole job, the two tool paths, the round over and the cutout, it all took about an hour and a half totally. I also found out here that the cherry wasn't the best wood to select, because as the CNC cuts on one direction, it makes the cherry kind of rough, which involves a lot of sanding after it's finished. Some of the internal parts were becoming loose, so I removed a few pieces that were freed up. I also slowed down the feed rate because I was getting a bit concerned there. I didn't want that bit to catch any of those sides. But it turned out just fine. Everything was cut, and I was able to remove the teapot from the blank and start sanding. I removed the teapot from the cherry blank, sanded it both sides, and gave it about 4 coats of clear lacquer. Project looks good.